Okay, so I have 4 o'clock, and let's go ahead and get started with the course. And what I'll do, again, as I normally do, I'm Randy Kearns. I'm your professor for Management 4450 and 5450. This week is Earthquakes and Personal Preparedness. I'll do a couple of things. Number one, I want to go over just basically the overview for the class for this week, and also talk about the key objectives. One other thing, let me pause the record just a moment. Okay, so we're back, and again, the main thing I want to do this afternoon is, again, just hit the highlights of what we need to be doing this week for the class. So the topic for the class this week is earthquakes and personal preparedness. Let me be sure that the screen I'm sharing, let's do this. Okay, and so I've got a couple of short videos that goes over different types of earthquakes and different locations of earthquakes. One of the things that we'll talk about in terms of earthquakes is understanding magnitude versus intensity, and then the scale of the damage. It is nice to know that of all the things that threaten us, at least here in the New Orleans area, earthquakes are not one of them. But nevertheless, regardless of whether earthquakes are a threat to us here in New Orleans or anywhere else you may live in the United States, I think the main takeaway from this will be, if you do live in other parts of the country, particularly on the West Coast, you're going to be in more prone earthquake areas. Other pieces that I've got in, again, short video clips, understanding just a little bit about magnitude versus, again, intensity. I also want to talk just a little bit about how earthquakes and tsunamis are linked. Typically, a tsunami, which is a very large catastrophic wave, occurs in the aftermath of an earthquake that has occurred typically at some point under the ocean, and how that wave effect can lead to, again, catastrophic damage in other parts of either the country where the earthquake occurred, or in some cases a continent away. Probably the most profound earthquake that produced a tsunami in our lifetime occurred in 2004, the Banda Aceh earthquake tsunami. And I do have, again, several video clips of it. It's pretty easy for you to play them. I won't spend a lot of time on that today. But again, I want you to understand that approximately 250,000 people were killed within 24 hours of the earthquake-induced tsunami. And the tsunami impacted particularly low-lying areas, but it impacted areas across, again, what was the South China Sea, which is primarily in the Pacific Ocean, and into the Indian Ocean. In fact, to the point that killed, I think, 89,000 people in the country of India, killed tens of thousands of people in Bangladesh, tens of thousands in Sri Lanka. And again, geographically, that's really not close to Indonesia, but it does give you an idea of just how far away the wave action carried on, and actually as far west as the east coast of Africa. Anyway, I also have, again, just to give you an idea of the magnitude of what can occur in the aftermath of an earthquake, how that can impact a country that's particularly close to the ocean, and how it can impact areas around the ocean, the coastline. In 2011, there was an earthquake and tsunami that impacted uh, Japan and impacted a nuclear power plant. It's also known as the Fukushima disaster. But if you look at this video again, it just reminds you of the magnitude and power following an earthquake and involving a tsunami. And as we've said with hurricanes, I'll also say with tsunamis, if you have a tsunami warning, the key is to get to a much higher elevation. Again, if you look at any of these, if you're traveling anywhere that's near a coastal town that's in an area that may be earthquake sensitive, it is important to know what the threats are, what the risk may be, and then where would be an evacuation point. In some cases, it may be, going to a higher floor in the hotel. In other cases, if you're in a low-lying area, it's going to be to get out of the low-lying area, obviously. Other pieces that I've included in this week's assignment. So the focus for the disaster for this week, or the particular threat that we want to think about, is earthquakes. But there's also two other shorter pieces that I've included, and that's personal preparedness, and that includes splinting. And splinting is the way that we would immobilize an extremity that may potentially be fractured or broken. And I've included information on both, again, personal preparedness, and there is an assignment associated with personal preparedness this week. And then I've also included the information on splinting. I've also included some information about the New Madrid earthquake and the New Madrid, the zone of risk for the fault lines around the New Madrid area. And I've got that in the presentation, so let me not get too far ahead of myself. Same thing on the East Coast. Just understand that earthquakes occur typically over much longer periods of time between when an area is at risk and building up pressure until that pressure is released. And so areas that are still somewhat prone to earthquake, but less likely to frequently occur, are areas generally east of the Rockies. Now, again, there's a fairly active fault area around the Memphis, St. Louis area, and I'll talk about that later in a presentation. And then there's also, historically, there was a catastrophic series of earthquakes that occurred in those areas, 1811, 1812. Again, we'll talk about it later. There was also a catastrophic earthquake that occurred in Charleston, South Carolina. If you ever go to Charleston and take a tour, one of the things you'll notice is they'll talk about the earthquake bolts that were inserted in a number of buildings to strengthen them and to help restore the city. Again, I've got more information about that. And then I've also got a couple of articles about personal preparedness as it relates both to this class and other things that we're doing in personal preparedness for our disaster topic for our class in general. You do need to complete Independent Study 450, and you need to complete a personal preparedness kit and either upload a list of items or a photo of your kit. And then you also need to include a personal preparedness plan. And then there's a personal preparedness quiz related to splinting. I think there's a quiz next week that includes some material about earthquakes. So there's no quiz this week on earthquakes, but there will be some quiz next week that will include some material about earthquakes. This week, your only quiz deals with personal preparedness that includes splinting, and then your other assignments for this week, IS 450, completing a personal preparedness kit, and completing a personal preparedness plan. One point I will remind you about the personal preparedness plan, and I've seen it occur in other classes, other versions of this class. So I've offered a couple of templates. For whatever reason, somebody will download the template. They may fill it out, but not save it and upload a blank template. I can't really grade a blank template. So be sure that when you save it and upload that for your assignment, that there's actual content in the document that you're submitting. And then if you're one of the students who are in the graduate part of this class, the 5450 students, you have a required paper that's due this week, and a required certificate above and beyond what's responsible for the students who are in the 4450 section of this class. If you have any other questions about what's due, please let me know, but let me go ahead and get started with the presentation. But again, the assignments that are due this week: certificate for IS 450, complete a personal preparedness kit, complete a personal preparedness plan and submit that. And you'll have a personal preparedness quiz. It's short, it's 20 questions. And then the questions related to earthquakes you'll see next week, and another quiz. And then again, if you're in the 4450 part of the class, the 2 assignments that are due for that. So with that said, let me go to the presentation for our class. So I'm going to stop sharing that screen and then move to sharing. So let's do. So I want to share this screen. Okay. Okay, and just to be clear, everyone can see the entry slide for 4450. Can someone tell me, yes, you can see that?
Yes.
Okay, thank you. Actually, let me go to this. Okay, so the 3 key words or key phrases that we use when we talk about protecting yourself from earthquakes is drop, cover, and hold on. There's historically been a number of different approaches and different pieces of advice in dealing with an earthquake. Probably the most important thing to remember about an earthquake is there's little to no notice prior to an earthquake. And the challenge with that is, you know, as catastrophic as hurricanes are, in most cases, we have hours, days, sometimes more than a week's prior notice. And so our response to and our recovery from a hurricane is typically better planned and better choreographed than it is with an earthquake. Earthquakes occur less frequently in terms of catastrophic earthquakes, but when they do occur and when they are catastrophic in nature, the recovery period is more prolonged and more profound. And that's in part because, again, there's a lot of planning and preparation for earthquakes, particularly in areas that are earthquake prone, but the response time between the time of us knowing about the quake and the quake actually occurring is seconds, maybe less than a minute. And so just to be able to create some type of an early warning system for earthquakes continues to challenge scientists in how we do that. I've got just a, let's see. Wow. Okay, so key topics. I want to be sure to talk about what causes an earthquake and how that theory has evolved through the years, how we measure an earthquake, again, in the context of magnitude and intensity, and then where are earthquakes most likely to occur, the geography of areas that are most prone to earthquakes, And then how bad can it be? And then what type of injuries can we expect following an earthquake? And what type of self-protection can we do? And then just briefly to talk, hit the highlights of personal preparedness and business planning. And so keywords that you will see again next week includes aftershock, earthquake, epicenter, focus, foreshock, hypocenter, liquefaction, Richter scale, modified Mercalli, and tsunami and volcano. So let me kind of go through those in a little bit of an order that we can best understand. So an earthquake is a shaking of the ground caused by a release of energy that occurs below the ground. And I've got some graphics shortly to help you understand a little bit more about what that means. But we don't know what a foreshock is until a large earthquake happens. We don't know if it's just a regular tremor or if it's a foreshock that's foretelling of a much larger, more catastrophic earthquake until the much larger, more catastrophic earthquake occurs. And so the connection between earthquakes and foreshocks, very difficult to know until after the earthquake occurs. And then how catastrophic can aftershocks be? In some cases, and I'll use the New Madrid earthquake series between 1811 and 1812, there were 3 very large, incredibly catastrophic earthquakes that occurred in the St. Louis, Memphis, Tennessee, New Madrid area. Now, the only advantage that we can look back on is the fact that very few people lived in those areas in 1811 and 1812. So there's actually very little documentation of what occurred, although again, from geographic history, it's a lot easier today for us to understand, again, just how catastrophic that event was, or those events were. And then the aftershocks, particularly in that case, there were hundreds of aftershocks that occurred, again, up to 30 years later. And when we talk about an earthquake and we talk about how catastrophic they can be, just again, understand we've designed buildings in the last 30, 35, 40 years to better withstand an earthquake, and to at least have seismology built into the construction of the building. So much so that actually University Medical Center, the new hospital that was built in downtown New Orleans, that replaced Charity, actually has earthquake support in it to withstand a certain amount of shaking and vibration. Not that New Orleans is an area for significant risk associated with an earthquake, but if while you're building a new high-rise building or large building like that, it's not that difficult to add that to the engineering and obviously to the construction of the building. Hypocenter, again, I've got graphics to help you understand that a little bit more. Liquefaction, the best way to think about liquefaction is if you shake soil, particularly sandy soil, but if you shake it quickly, it actually behaves like a liquid. And what that can do is that can lead to substantial structural collapse. It's been built on top of soil like that. And that's why in many cases, they dig as deep as they do to try and get down to bedrock and something that they can anchor into that is down below the soil that doesn't hold together as well during active shaking. Again, the moment magnitude, something that we've historically referred to as the Richter scale, and then modified Mercalli. I'll talk about that in the context of some images that I have. And the tsunami is, again, a huge sea wave. Some refer to it as a tidal wave caused by an earthquake. And just understand the relationship between volcanic activity, earthquakes, and tsunamis. Those 3 are distinctively linked together. And and just because there's an earthquake doesn't mean there's volcanic activity, but it does mean that there's probably active volcanic activity somewhere on that plate area. The most active area on the planet is something called the Ring of Fire, and I've got some images to better help you understand that too. So when there's a rupture line, a rupture point, whether it's vertical or lateral, that movement of rock is typically what's referred to as an earthquake. Kyoto in 1871 was really the first to describe it, and he really thought it was the ground breaking apart that caused the earthquake, as opposed to the earthquake causing the ground to break apart. The 1906 earthquake was really the first time that we saw a lot of science come out of what had occurred as a part of the earthquake. Just understand, in 1906, we didn't have a clear understanding of what was going on in the world, but we did know that this catastrophic earthquake occurred in San Francisco that killed people, but left tens of thousands homeless, burned down most of the city, although that was really from a different reason we'll talk about shortly. But also understand that half a world away on the other side of the planet, Mount Vesuvius was erupting. And there were, again, if you think about it being more than 100 years ago now, there were people who thought the world was ending, that the earth was splitting apart, because you've got San Francisco having this catastrophic earthquake, and again, half a world away, Mount Vesuvius is erupting. And so there were people reminding others that the end of the world is near and the earth is breaking apart. Obviously, it didn't come to that, but it does give you an idea that sometimes when we don't understand science, we link our own cause and effect without understanding the basis for what's going on. Alfred Wegener was really the first person to propose a notion called drift hypothesis. And what he did was he linked some research that had been done by different types of researchers that they couldn't fully explain. And once he linked it together, he envisioned that there was once this large landmass referred to as Pangaea. Pangaea is a Greek word meaning all lands. But he envisioned that there was this large landmass that at some point must have broken apart and drifted into different places. I actually have a video of that, of an animation of that. And early on, he was again dismissed rather outright. But over time, we began to understand, and later was able to confirm that his hypothesis in 1912 was actually true. Heiss in 1962 and Dietz in 1961 both conducted studies that actually confirmed that different plates of the continents were drifting and were moving and were constantly moving. Now, they're moving in very small increments, maybe an inch a year, maybe half an inch a year. But what that tells you is this constant movement that takes place of the plates surrounding the external plates surrounding the planet. As those plates move against each other and they build up pressure until there's a release of that pressure. When there's a release of that pressure, that's what produces the earthquake. Anyway, so drift hypothesis basically starts out with one large continent, and as that large continent, and because we had orthopaleontologists, people who study prehistoric birds, and botanists that were also looking at the origins of, they were trying to understand why there were flowers and at least fossils of flowers in certain parts of South America, Africa, India, Antarctica, and Australia. And then fossils in India, Antarctica, and Africa, that there was no other way to explain how those same organisms, those same animals, those same plant structures could have existed on different continents at the same time, unless at the same time they were all connected as one continent. And that became the basis of his, at least his hypothesis, what was drift hypothesis. And then he later looked for things to try and confirm or refute his hypothesis. And part of that was understanding plate tectonics. There's a couple of ways that plate tectonics occurs, whether it's shifting over top of plates, shifting over top of one another, or converging against each other, or transforming, sliding by each other. And another way to think about this also is, where was the energy released? If the energy is released very deep into the earth, by the time it reaches the surface, it's less likely to produce a substantial amount of damage. And so that moment of release, something that we would measure historically on the Richter scale, that moment magnitude may actually be may reveal that a great deal of energy was released, but because it was released deep into the earth through a lot of density, it may not have produced a great deal of damage at the surface of the earth. On the other hand, if the focus, if the point where, so the focus is where the energy, the actual energy is released in the earthquake. If that focus is very close to the surface of the earth, then the damage that translates into at the surface is catastrophic. As an example, the earthquake in Haiti, I think it was 2010, the earthquake in Haiti was about 7 miles below the surface of the earth. And because it was a really shallow earthquake, and because construction standards in Haiti were not exceptional, it led to catastrophic damage and claimed the lives of more than 200,000 people. When we talk about the epicenter, we're talking about the place on the surface of the earth above where the energy release took place. And where the energy release took place, that is the focus of the earthquake. So the focus occurs down below the surface of the earth. The energy moves up through the surface, up to the surface, and the exact point on the surface of the earth above the focus is what we call the epicenter, okay? And then again, just the best way to think about this is also to think about how volcanic activity interacts with this. In some cases, there's most of the more active volcanoes are around, again, something we call the Ring of Fire, but it's around the Pacific Ocean. But obviously there are other places. There's still active volcanoes in the Caribbean. There's still an active volcano in Mexico. There's an active volcano in Hawaii. And so there's still some that are reasonably close by, but most of the active volcanoes are either in Europe or Indonesia, specifically Indonesia and the Southeast Pacific Ocean. And so again, from plate tectonics, this is a really good graphic that if you look at the red dots, the red dots give you an idea of significant earthquakes that have occurred in the last 30 years. And there's a particular area, again, that goes from, so this is Japan, this is Korea, Indonesia, New Zealand. And so you have this Pacific plate that then follows up the San Andreas Fault, the west coast of Canada, the Aleutian Island chain that's a part of Alaska, and then again completes the circle. And so the most active tectonic area in the world is, again, the Ring of Fire, and it's areas that are most likely and most susceptible to earthquake. And certainly Hawaii is a hot spot. Hawaii is a product of volcanic activity that's come up through the Pacific Ocean and has constantly formed this ridge of islands through the years, through the last several million years. And if you ever get a chance to go to Hawaii, there's 12 fairly large islands. The largest island is also referred to as the Big Island. That's where Kilauea is located today. And Kilauea was quite active last year, 2 years ago. And so anyway, it does give you a clear understanding of just how active a volcano can be. And there's constant earthquake activity. If you spend some time on the Big Island, you won't stay there 30 days without having felt a tremor about every 48 to 72 hours. It's pretty common. The tremors are very small, very light. They're not profound. And most of the earthquake activity is absorbed by the constant activity of the volcano, releasing energy in that fashion. So there's not significant earthquake activity that goes on there, primarily because there's a volcano there that gives it a chance to release energy in that fashion. In some cases, it's a combination of both, though. And let me get on into a couple of other examples. Let me check my time to be sure I'm not rambling on too much. You'll also notice, again, down through Central America and down the west coast of South America is where the greatest activity is located. And it is important to understand, again, as we see where earthquakes take place and what type of earthquake activity has occurred, how these tectonic plates are constantly shifting and moving, that builds up energy, releases the energy, and causes the earthquake. So the other thing to remember is to also understand how this activity can take place in areas where people live, and how that creates substantial impact of people and anyway. So magnitude versus intensity. Magnitude we measure in moment magnitude, and we've historically measured that on the Richter scale. The main thing about moment magnitude is it helps us understand how much energy was released at the focus point. Remember, we talk about the focus, and then at the surface above the focus is the epicenter. Well, at the focus is whatever energy was released, the greatest energy release, that's our moment magnitude. But that doesn't always give us an idea of just how widespread the damage or how substantial the damage is. And for that, we use something called the modified Mercalli scale, the MMI, or modified Mercalli index. And the way that works is that helps us understand how widespread things are. And MMI will also give us an idea of how much damage to infrastructure has occurred. A part of being involved in rescue operations or response operations also includes how much infrastructure was damaged. Do we need to move people out of the damaged area, or is the damage limited and does not involve a lot of the infrastructure, and therefore we can move responders into it? And on the right is a scale, and this is somewhat of an equation of how much damage can occur. On the left is your modified Mercalli index scaled from 1 to 11. Actually, it goes from 1 to 12. And then on the right is a 1.5 to 7.5 in terms of moment magnitude or the amount of energy released. And it gives you an idea of how it directly relates to it. But as you move farther away from the epicenter, obviously you'll have less damage. And so understanding what the modified Mercalli score is for different areas will give you an idea, will give us an idea of how widespread the damage and how much damage has occurred in a widespread area. So again, the Richter magnitude scale, again, also known as the moment magnitude, gives us an idea of just how much energy has been released, but it really doesn't tell us how widespread the damage is. And then if we convert moment magnitude to approximate energy being released by TNT or dynamite, this gives you an idea of what that equation is like and how compounding the factor becomes with a much larger magnitude earthquake. The highest magnitude earthquake to ever impact the United States that has been measured occurred in Alaska. And actually, I think I've got that, so let me not get too far ahead of myself. Again, modified Mercalli, this is 1 to 6, and then this is modified Mercalli 7 to 12. The whole point to understanding modified Mercalli is it does give us an idea, again, of just how widespread the damage. And the advantage to that is, again, it helps us understand, do we need to evacuate people out of there or do we need to push resources in to help them and help them stay there? And if we look at the areas that are most susceptible to earthquakes and earthquake damage, the areas that I don't think would surprise you, all of the West Coast, state of Washington, Oregon, California, a little bit into Nevada, Idaho, Montana, Wyoming, Utah, Arizona, New Mexico. The areas that probably would surprise you a little bit more than most here in what's referred to as the New Madrid quake zone, and there's frequent low intensity tremors that occur there all the time. And I would go over here to Charleston and say the same thing. There's low intensity tremors that occur in Charleston and the area around South Carolina on a regular basis. I used to own a house up here on the South Carolina, North Carolina border when I went to school at the Medical University of South Carolina. And I had to have earthquake insurance. It was the first time in my life I had to have a rider for earthquake insurance. And so it did remind me, though, one more time that I was in an area that was a little bit more active for tectonic activity. Now, given what it cost, it wasn't a big threat, but it was a threat. I can imagine trying to buy earthquake insurance over here in the California area. And then obviously Alaska and Hawaii are also very active for earthquake activity. I will add, it's not included in this image, but Puerto Rico, so the islands of the Caribbean are one of two types of island. Number one, most of them are volcanically produced, and therefore there still may be some volcanic activity in the Caribbean, but it's to a much lesser extent. But they're still, because they were produced by volcanoes and because there's still a tectonic plate there, many of those areas are still susceptible to earthquake. As we saw in Haiti, sometimes we see in the Dominican Republic, but we saw in Puerto Rico just in the last several years as well. This gives you another image, again, of earthquake activity, and probably the other two areas that I didn't mention, but there was actually an earthquake in 1775 referred to as the Queen Anne quake that occurred here off the coast of New Hampshire, Massachusetts, in this area north of the Boston area. And so if we look at the world map and we overlay just a little bit of, again, here's the tectonic plates, and just understanding how those plates are constantly drifting in very small distances each year. Again, approximately an inch a year in some cases less distance than that. But as they move, at some point, they continue to build up pressure. And these are two very large, very heavy rock plates against each other. And at some point, there's going to be a release of energy. And when there is that release of energy, that is when an earthquake takes place. But again, if we look at the plates, and then we overlay that with the world population, and then if we look at the dark areas being the areas where the greatest number of people live, and then we overlay the two together, this is what we start to see. We see that, again, the plate activity is in some cases impacting more than 60% of the world's population. And again, this kind of gives you that back and forth look of, this is the world population, and this is where the plate activity occurs. Your most populated countries in the world, China is the largest, I think about 1.5 billion people. India is the second largest, about 1.3 billion people. And again, just understand the amount of plate activity that takes place in India and China is substantial. And therefore, when they have earthquakes, they have substantial injury and loss of life. Again, that's where the population is, and that's where the plates are. Okay, so let's kind of move on to the top 10 greatest disasters of all time that kill the greatest number of people. You're typically going to talk about either a flood or an earthquake. And if we look at earthquakes, 1556, an earthquake in China killed an estimated 830,000 people. Turkey, 15 centuries ago. But China in 1976, China in 1920, Indonesia in 2004, and the 2010 Haitian earthquake. And again, I've got several other historical earthquakes to remind us of just how catastrophic things can be. So when we compare earthquakes, again, date that it occurred, but time of day is even more important. And then what's the magnitude, what's the moment magnitude in terms of energy released, and the epicenter modified Mercalli, and then how far reaching did the damage occur, how many were killed, how many were injured, and were there other interesting facts. So let's look at a handful of them. I start with the New Madrid quake. It occurred north of here. It was 3 quakes in a series of, the first one, I think the first one was December 10th, 1811. The second one was in late January, and the third one was in February of 1812. Only because there were not substantial numbers of people that lived in the area was the death toll limited. Had that same series of earthquakes occurred today, the damage would be catastrophic and would be far-reaching. And again, there were hundreds of aftershocks for 35 years. What types of changes that took place to the Mississippi River. And again, a lake was formed. It just reminds you again just how catastrophic that event was. Okay, so December the 16th, that was the first earthquake that took place in the New Madrid series. There was some shaking felt in New Orleans and some damage, an intensity of a 3 or 4 of modified Mercalli. Again, that's low in intensity, but it still reflects some damage, such as a chimney falling, some cracks in the sidewalk, things like that. Although cracks in the sidewalk in New Orleans is not unusual, it just gives us a new reason to have one, I guess. The New Madrid quake, January 23rd. Intensity was a little bit higher in New Orleans that time than at other times. But if you'll also notice, there was damage in New York, Maryland, Toronto, Canada, Virginia, Baltimore. Why aren't they reporting damage west of the Mississippi? And that's because in 1812, there was no correspondence. The only people living west of the Mississippi were tribal nations. And obviously we don't have recorded records, but it's safe to say the damage was also just as catastrophic in Texas and further west as it was further east. And then February the 7th, again, gives us still some more, gives us the third of the three large quakes that occurred in New Madrid. And again, a little bit larger damage, but again, from a modified Mercalli standpoint, intensity of 5 is still not substantial, but it does remind us that there was some damage here in the after effect of the New Madrid quakes. This also shows that it occurred, the December quake occurred at 7:30 a.m. So let me move on to Krakatoa. Krakatoa is probably the most well-known, most written about earthquake, maybe at any time in our history. And it's partly because of all of the different things that occurred in the aftermath of Krakatoa. The difference between 1883, when Krakatoa occurred, and today is air travel. Had Krakatoa occurred today, it's hard to believe that we would have air travel for weeks, maybe months, in the aftermath of the earthquake and volcanic explosion. So it produced a tsunami wave of almost 100 foot high. 37,000 were killed, and it's only because there weren't a lot of people that lived in the islands at that time. It's the loudest sound ever recorded on the planet. Krakatoa is in Indonesia. If you think geographically where Indonesia is on a globe, you think where the English Channel is. They measured shock waves in the English Channel 7 different times, and that's believed from the wave action that was generated around the planet in the aftermath of the explosion at Krakatoa. Record rainfall in Los Angeles and San Diego, 38 inches and 26 inches, because all of this debris moves up into the atmosphere, seeds the clouds, creates this constant rainfall, created substantial climate change for about 20 years thereafter. Some really extraordinary climate-related events took place in the next, again, 16 to 18 years after Krakatoa. Blizzard in 1888 killed hundreds of people in New York, killed more than 100 school children stranded in their schools. It snowed in New Orleans in 1895, 8 to 10 inches on Valentine's Day. And there was also known as the Mardi Gras blizzard in 1899. But it gives you an idea of just how dramatically it changed the global weather for about 20 years. I think I have some other images from Krakatoa. Yeah, 67% of the island was destroyed. All but 10 people who lived on the island were killed. Bodies washed ashore in South America and Africa over the next 6 months. No sunlight in the immediate area for 3 days. It's also important to recognize, if you see this famous painting called The Scream, it's most likely because of how the colors of the atmosphere had changed the sky around the world because of the amount of sulfur that had been ejected into the atmosphere following the eruption. He started that painting shortly after the eruption, and he finished it about 10 years later in 1893. Let me move on to the Charleston, South Carolina quake. Running short on time, so let me be sure and hit just a couple more of these things before I wrap up today. But again, the Charleston quake occurred in 1886. The the main point about, if we think back to 1886, so the quake occurred on a Friday night. So August 31st, I don't have it listed here, but this was a Friday night just before 10 p.m. And as you know, if we think about what was the United States in 1886, it was primarily all points east of the Mississippi River. Now, there was certainly the West Coast, but there was very little in between the Mississippi River and the West Coast. So for the most part, the United States was east of the Mississippi River. And the only way to communicate with each other almost real time in those days was by telegraph. And telegraph stations started reporting the earthquake to each other and started communicating with each other. The quake was felt in New Orleans and Atlanta and Boston, Chicago, Milwaukee. It was felt in Cuba and Bermuda. But the one big city that was not reporting anything at all was Charleston. And that's actually how they were able to narrow down that probably the damage occurred closest to Charleston. Because at that time was a significant city. And then the largest earthquake to occur in terms of the most catastrophic to occur in the United States, the 1906 San Francisco earthquake, killed approximately 3,000, displaced between 300,000 and 400,000. Part of the challenge with that is one of the first casualties and one of the first people to die in the earthquake was the fire chief. He was killed very early into it. A large piece of debris in the fire station fell, struck him, and he died of a head injury. And it left the fire department, who was primarily responsible for the emergency response, without significant leadership. And so the fires burned for several days. There was a lot of volunteer help that was offered, including from the military, from the Presidio. They began experimenting with trying to use dynamite to blow up structures so that they wouldn't catch on fire, but they were using a type of dynamite that actually created fire as the explosion took place, and actually spread fire throughout the city. They managed to burn down most of the city in a 4-day period. And so while 3,000 being killed is substantial, it wasn't nearly as catastrophic as the fact that, again, over the next 4 days, the entire city managed to burn, other than those areas near the wharf. The fire department that was left fighting fire without a lot of, most of the water lines were destroyed in the earthquake. And so there was not a lot of fire hydrant water pressure. So the area close to the wharf, close to the port area, was pretty easy to save because they had a water source. But they had very few water sources in the rest of the city, and most of the rest of the city burned. Anchorage, Alaska is really the most significant earthquake, at least in moment magnitude, or measured on the Richter scale. The moment magnitude was 9.2, also known as the Good Friday earthquake. Again, it produced a tsunami. Although the earthquake occurred in Alaska, it produced a tsunami that killed 11 people in California and 1 person in Oregon. Just gives you an idea. Again, fishing boats were reported sunk off the coast of Louisiana, and Wales water was seen sloshing in South Africa. It does give you an idea of just how much the impact was felt around the world. The Banda Aceh earthquake in 2004, again, major earthquake, 9.1 to 9.3 moment magnitude, and then Macaulay intensity up to an 11. Killed almost a 250,000 people in 14 countries. This gives you an idea of where the earthquake took place. Again, it was just off the shore, but then as it spread out, the tsunami across the Indian Ocean, and for that matter into the South China Sea, which is the Southeast Pacific, it killed thousands of people in countries that were nowhere close to Indonesia, where this earthquake took place. The earthquake in Pakistan occurred October 8th, 2005, killed nearly 90,000 people. Again, it was a significant earthquake. We never heard that much about this. And the reason we didn't was what was going on in the United States in October of 2005. We were in the immediate aftermath of Hurricane Katrina. So we were really focused on Katrina. And so much of the world press, not that it wasn't important, but certainly wasn't nearly as important as what was going on in our own country. And so that's why we knew less about this. But again, it killed tens of thousands of people. The Haitian earthquake was 2010. The real challenge with the Haitian earthquake, again, if you've been to Haiti before, wonderful people, just understand it's a truly impoverished nation. And so whatever they're building, they're doing the best they can, but obviously there's not a lot of building code. And so there's not a lot of support structure in place. There's not a lot of engineering that takes place. And so when these structures collapse, and they did, you have people that are living on life's edge as it is. When you have something this catastrophic, it's very easy for thousands and tens of thousands, and in this case, hundreds of thousands to die. I had a couple of friends who were involved in the response to Haiti. Chile occurred in February of 2010, also the Chilean earthquake. The big difference between the Chilean earthquake and the Haitian earthquake was the Haitian earthquake, the hypocenter was 8.1 miles below the epicenter, or where the focus point was. In the Chilean earthquake, the hypocenter was about 20 miles below the surface. And so, and the density was great. And so what it did was it allowed a lot of the energy to be absorbed without it translating into substantial damage. Now, I mean, there was still a lot of damage, and there were hundreds of people who lost their lives, but not thousands, tens of thousands, and hundreds of thousands. And the Chilean earthquake should concern us simply because of another earthquake in Chile in 1960 left more than 100 people dead from a tsunami in Hawaii. So again, from a self-protection standpoint, stop, drop, and cover. Things that we used to talk about that we don't talk as much about. There once was a time we talked about standing in a doorway. Just the point to that was that is a strengthened part of the structure, but there's probably just as much risk from falling debris. If you can find something substantial that's close to the wall, such as a desk that you can get under, that's the safest thing to do. There's also a point about running outside. It's really best not to run outside, just simply because of all of the things that are falling from buildings that are shaking or have been shaken. Yeah, do not run outside or into other rooms. Again, the room you're in, stay in the room you're in, get close to a wall and get under something sturdy and stay there until the shaking stops. Don't stand in a doorway. Again, at one point we believed that to be a safe place, but that's no longer a safe place. And if we look at earthquake data, we see that the most common injury is fractures and dislocations. We saw that in Haiti. We've seen that in a number of locations. And that does help us understand what's the best injury to prepare for in the aftermath of an earthquake as well. And that is a fracture or dislocation. And that's why the other presentation for this week that I won't go over, but I will ask you to review deals with fractures and dislocations. Self-aid and buddy care, rescue yourself, rescue your friends, evacuate the area, avoid going back into buildings once you evacuate the area. Don't leave the building while the shaking is taking place. Wait until the shaking has subsided before you leave. Something that's common after an earthquake is you see a lot of tent cities that are set up away from buildings. That's really common, and that's because you want to get away from buildings until someone can who's an engineer who can seismically evaluate is the structure safe to go back into. Again, the most common injury is a fracture. I did include a fracture care for an injury such as a fracture or dislocation. Home and mitigation strategies, what type of safety features have you built into your home or into your business? What are some things that you can do to prepare yourself for it? I will tell you from an emergency planning standpoint, if you're a business that needs to continue to operate and you need to push out messages related to the disaster, sometimes those businesses operate something called a dark site, which is not readily accessible, but it's got a lot of important information on it that if suddenly you do have a disaster, that's the site that you go in and point the landing to that website and you bring up active information related to it. Anyway, and with that, I'll say, do you have any questions? So let me recap again, the main things that, let me escape this and let me be sure that what I'm sharing, let me stop sharing that and go back to sharing this just a second. Again, the main things that are due this week, the content of this presentation that we just went over will be in next week's quiz. Your only quiz for this week deals with splinting and personal preparedness. And then you need to complete a personal preparedness plan and upload it. You need to complete an emergency preparedness kit and upload a photo of it or tell me what would be in it. And then if you're, and complete IS 450. If you are in the 4450 section of this class, the graduate section of this class, you also have a paper due and a second independent study certificate, IS 325. If you want to take IS 325 and you're in the 4450 program, you can, we can work that out as a substitute for a certificate you may have missed previously or in the future. Anyway, if you don't have any questions, do you have any questions? Let me ask one more time.
No questions.
Yes, I have a question.
Yes, go ahead.
For the kit and stuff like that, that's not the same as the other one you're requiring, right? The actual plan, like the kit is just like what you actually gonna have as in like supplies and stuff.
So two things, a personal preparedness plan will talk about communication with your family and evacuation of your home. And then a personal preparedness kit will be how you would assemble, what would you put in a personal preparedness kit. With us living in a hurricane prone area, we need to think in those terms more than an earthquake, but certainly what would you have in your personal preparedness kit?
Oh, okay, thank you.
Sure. Are there other questions?
No, sir.
Okay, I appreciate your time. And again, if you have questions, please let me know, but otherwise you all have a good day.
I